Hello everyone, this is Rotaract Senori Silva and welcome to the fifth session of Rot to A Plus project initiated by the Rotaract Club of NSBN. And today we are going to continue the rest of the lesson. So I'll screen share and let's move on with the lesson. Okay, so last week I told y'all we entered into a very new section which is chemistry, and we learned about elements, atomic structure, how to put the atomic number, the mass number, how to find it. We learned about the nucleus, we learned about the protons, neutrons and electrons. So today we are going to talk about the second part of that lesson, second part of the third unit, which is compounds. That is the part we're going to talk about. So I hope you all can remember what is an element and how to write the mass number, how to write the atomic number. So in case if you all can't remember, you all can go and quickly watch the video I did last week for y'all. Okay, so a quick recall: mass number is the sum of protons and neutrons, and atomic number is the number of protons. Mass number, sum of protons and neutrons, whereas atomic number is the number of protons. Okay, so that's where we stopped last week, and today we're going to continue from the second part, which is compounds. Okay, so compounds are formed by the chemical combination of two or more elements in a certain ratio. Children, if you all can, highlight that part because that is really, really important. What are compounds? Compounds means, children, two or more elements getting together in a chemical way, okay, chemically in a certain ratio. ඒ කියන්නේ elements දෙකක් හෝ ඊට වඩා වැඩි ප්‍රමාණයක්. එක element එකක් නෙමෙයි. element දෙකක් හෝ ඊට වැඩි ප්‍රමාණයක් combine වෙනවා. හැබැයි physically නැහැ. Chemically. Chemical combination, that is really important. Okay? Chemically and in a certain ratio. Okay, so I'll teach you all why we use these two words, certain ratio, when we talk about the definition of compounds, because it's really important. Okay, because children, සමහරලාට element same වුණත් එයාලා එකතු වෙලා තියෙන ratio එක වෙනස් වුණාම ඒ compound එකේ තියෙන characteristics ඔක්කොම වෙනස් වෙනවා. So the characteristics depends on the elements as well as the ratio they are combined together. Okay, so compounds are formed by the chemical combination of two or more elements in a certain ratio. I hope that the definition is clear. Some of those compounds exist in nature as molecules. මේ compounds සමහර ඒවා nature එකේ තියෙන normally molecules විදිහට එකතු වෙලා තියෙන්නේ. හරිද? Since those molecules contain atoms that are different from one another, they are called as heteroatomic molecules. So children, when you hear this word heteroatomic molecules, you all have to remember what homoatomic molecules are, because that part we learned last week. Homoatomic molecules are when there's a molecule where atoms which are same. Again, hydrogen නම් hydrogen විතරයි. nitrogen නම් nitrogen විතරයි. අර එහෙම එක atoms වල තියෙන ඒවා combine වෙන ඒවට අපි කිව්වොත් homoatomic molecules කියලා. So this is the opposite of it, heteroatomic molecules. ඒ කියන්නේ molecules containing atoms that are different from one another. ඒ කියන්නේ දැන් N දෙකක් නෙමෙයි, H දෙකක් නෙමෙයි, O දෙකක් නෙමෙයි. No, because those are homoatomic molecules, more like that, because those are same atoms combined together. But here heteroatomic molecules are when atoms are combined together and those atoms are different from one another. Okay, so an example has been given here: hydrogen chloride molecule. HCl is the shortened form of it. It's an acid, children. So I'm not sure whether being in grade 9, whether you are given access to use HCl for any of the experiments. I don't think so, but in O levels, or else if you are thinking of doing science for A levels, then for sure you'll be able to, you know, work with HCl, but not concentrated HCl, where the HCl what do you call, the composition is really high because it's dangerous. But most of the time diluted hydrogen fluoride, where the concentration of HCl is less. Okay, so it's not that dangerous when compared to concentrated HCl. So that's not something related to our syllabus right now. I was just comparing diluted HCl, which is less concentrated, and concentrated HCl, where the concentration of HCl acid is more. Okay, so now here HCl is hydrochloride molecule. Y'all can see this, you know, just by looking at this small illustration, where hydrogen chloride molecule is formed by one hydrogen atom and one chlorine atom. Okay, so we learned about these elements in the last week, hydrogen and chlorine. So children, hydrogen chloride molecule is made. Now this hydrogen chloride molecule is also a compound. Why? Because two or more elements are being involved in this, and they are in a certain ratio. You all can see that one hydrogen atom is being combined with one chlorine atom. So the ratio is 1:1. Okay, hydrogen chloride molecule is formed by one hydrogen atom and one chlorine atom. So in case if someone changes this ratio, then it won't be hydrogen chloride molecule. The characteristics will differ. Even though the the elements are same, if the ratio is different, children, the characteristics, the chemical characteristics of the certain molecule will be different. Okay. So this is HCl. If you are being advised, if you have been asked to illustrate the formation of a hydrogen fluoride molecule, this is how you should do at this stage. Okay. Thus, a main difference between elements and compounds is that elements is composed of the atoms of the same kind. That is what I told you. So, elements, children, the atoms are of the same kind. Now, if you take H2, two H atoms are together. If you take N2, two N atoms are together. But the difference here is compounds have been formed from atoms belonging to two or more kinds of elements. The atoms are different. So if you take an element, their children, it is composed of atoms of the same kind. H2, N2, Cl2, likewise. But compound is not like elements because there are atoms which belongs to two or more kinds of elements. They're different from one another. So there's an illustration of the water molecule here. I think water molecule, the formula is really, really easy and a lot of people know it. H2O. Okay, so H2O is the chemical name, the name you use to the water molecule. Why, children? Because there are two H atoms and one O atom in H2O, and it is being made as a molecule. Water molecule can. Okay, H2O, H atom dekai O, and this is how it exists. Then anit thawa then H2O, if you take a glass of water, children, do y'all think it's just, you know, it has just one water molecule? No, there are so many water molecules in this in a glass of water. So they are connected with one another. Now, if you take H2O here, then this H over here is being connected to another O. It will say H connected. The molecules have been connected. Okay. So H2O is the water molecule, the formula of water molecule. And why do you call H2O? Because there are two H atoms and one O atom. The ratio is 2:1. O O is to H, 2 is to 1, because there are, sorry, O is to H, O is to H now, 1 is to 2, because there's 1 O atom and 2 H atoms. Okay. Carbon dioxide molecule is like children, CO2. That is really easy, and it's like this in a linear way. Killing thing. When we have a triangle with it, okay. So carbon dioxide. If you have been asked to draw a carbon dioxide molecule, you are killing a thing. Water molecule is a triangle. So CO2, C is to O, 1 is to 2 ratio. And then you have the methane molecule. What is methane, children? It's actually a gas, and it's the simplest one in the paraffin series of hydrocarbons. Methane gas. Okay. Hydrocarbons C and H. hydrocarbon. CH4 methane can. So methane molecule is been illustrated here. So what is the composition of methane molecule? C and 1 carbon atom and 4 H atoms. So it's been comprised. It comprises C carbon atoms and hydrogen atoms. So that means it's a hydrocarbon as well. Okay, hydrocarbon is something which has carbon atoms and hydrogen atoms. So methane molecule, which is CH4, is the simplest one in the paraffin series of hydrocarbons. Okay. So if we talk about the composition of CH4, there are 4 H atoms and 1 C atom. C is to H ratio is 1 is to 4, because there are 4 H atoms and 1 C atom. So this is how you illustrate the methane molecule. Okay. And then you have the ammonia molecule. It has 1 N atom and 3 H atoms. How do you write it? NH3. NH 3. Okay. So if you want me to write it and show, okay. So how do you write this, children? N H wait, N. I'm sorry about the letters because it's a bit hard. NH3. This is how you write NH3. Okay. And let's see, I can go. Yeah. Okay. So this is CH4. How do you write CH4? But I can't. Yeah. CH4. How do you write it? C H 4. Okay. So this is how you write CH4, and CO2. I'm sure you all know it, and so that's how you do it. Okay. Let's now go to the rest of the part. So this is the ammonia molecule. It has 1 nitrogen atom and 3 H atoms. 1 nitrogen atom, 3 H atoms, NH3. Okay. So now there are specific chemical symbols for compounds also. So we learned the chemical symbols for the elements, and likewise, children, there are specific symbols, unique symbols for the compounds as well. Okay. So you call it chemical formula. And yeah, so like they have told y'all will further learn about it in a very more detailed manner when you go to higher grades in grade 10, 11, and A levels if you're going to do science. So you'll learn about it in a more detailed way. Okay. So water is H2O. These ones, children, the ones they have given, there are 7. These ones try to keep in mind. Okay, these 7. If it's difficult, yeah, I think even if it's difficult, it's good if you all can keep them in mind, because those are some compounds which are very, very common. Okay, even if you keep in mind this year, and if it doesn't appear on your papers, it will still be good for your grade 10 because in grade 10 and grade 11 you all have to memorize. Okay. So water is H2O, like I told you all. There's one H atom and there's one O atom and two H atoms. But now they have asked us only to write the elements that are in this compound. So they have just written H and O. Okay. So glucose is C6H12O6. There are 6 C atoms, 12 H atoms, and 6 O atoms as well. I think you all know this because this is being used when we write the chemical formula of photosynthesis. Okay, so for photosynthesis we used this. Why, children? Because this is the main product, the outcome of photosynthesis. If you all can remember, what is the chemical formula of photosynthesis? H2O plus CO2, and then you draw an arrow, write sunlight on top of the arrow, and below the arrow you write chlorophyll, which is the pigment that gives the green color to the plant. And what are the two products? The main product is glucose, which is C6H12O6, and what is the other product? That's oxygen. So carbon dioxide, CO2 plus H2O, arrow, on top of the arrow sunlight, below the arrow chlorophyll, and the two the outcomes, the byproducts are, the main one is glucose, which is C6H12O6, and the other product is O2, oxygen. Okay. So glucose is something which is really, you're something you're really familiar with. Methane, I told you all, CH4, which is the simplest member of the paraffin series of hydrocarbons. It is a gas, a hydrocarbon, because there are carbons and hydrogens only. And then you have carbon dioxide. That is really easy because we know about it, because we learned it when we were small, when we were learning about photosynthesis as well. What is photosynthesis, children? It's not in the lesson. I'm just trying to make you remember. It's the plant producing green plants. Okay. Let's come to the lesson again. So sodium chloride. Sodium chloride is common salt. Luno. Okay. Sodium chloride. මොහොදු වතුරේ තියෙනවා. sea water එකේ තියෙනවා ගොඩක් වෙලා. ගොඩක් වෙලාට කියන්නේ තියෙනවා. හරිද? මුහුදු වතුර sea water is salty because of sodium chloride. Because there's sodium chloride, and there are other types of salts as well. So for now, for this age, y'all can just learn about sodium chloride. So sodium chloride is, children, NaCl. I think y'all can remember why sodium chloride is being denoted with the symbols Na and Cl. So Cl is that y'all know because chloride and chlorine. Chloride is chlorine. So you put Cl. But why did we put Na for sodium? I hope you all can remember. Why did we put Na for sodium? We learned it last week because you can't put S. Why? Because letter S is being given to sulfur. So you can't use the same symbol for sodium as well, because sodium starts from letter S and sulfur also starts with the letter S. You can't give S for both. Okay. So because of that, we had to go to the next option where we denote sodium with the first two letters of its Latin name, which is natrium. So the Latin name of sodium is natrium. So we denote sodium as Na. Okay. So children, coming back to the lesson again, to what we were discussing right now, sodium chloride and NaCl, the two elements are Na and Cl. මෙතන elements හතරක් තියෙනවා කියලා N එකයි A එකයි C එකයි L එකයි කියලා ලියන්න එපා. Na is one element, which is sodium, natrium, and Cl is chlorine. Okay, NaCl. And then you have copper sulfate. It's CuSO4. Cu, it's the same. There, it's been derived from its Latin name. So there are three elements: Cu, S, which is sulfur, and O, which is oxygen. And then you have calcium carbonate, calcium Ca, and carbonate part is CO3. So there are 3 elements as well. So now we all can see, children, the elements that are being used to produce these compounds are different from one another, and that is why we call them as compounds. Okay. Elements contained in the smallest unit that form a compound cannot show the properties of that compound, and the different compounds formed by even the same elements have different chemical properties. Yes. So that means, children, so even if the elements, then අපි තුමුකෝ එක example එක යට තියෙනවා. දැන් අපි තුමුකෝ මෙතන CH4 තියෙනවා, methane, component of biogas. Hexane තියෙනවා, benzene තියෙනවා, acetylene තියෙනවා. A gas burned to generate heat essential for welding metals. Ethane තියෙනවා. This has been used to make polythene. So if you take these 5, y'all can see methane, hexane, benzene, acetylene, and ethane. They are made out of carbon atoms and hydrogen atoms. They are hydrocarbons, to be more specific. Okay. Methane is also made out of carbon atoms and hydrogen atoms. Hexane is also made out of carbon and hydrogen atoms. But there's a big difference why they are being combined in different ratios. Okay, so because of that, children, the characteristics or the chemical properties of these compounds are different from one another. The chemical properties of methane gas, which is CH4, is different from the chemical properties of the hexane gas, which is C6 and H14. So if you take benzene, the benzene compound, it's C6H6. So that is different from the methane gas, which is CH4. Why? The ratios are different. So even though the compounds are being made out of the same set of elements here, when you take this example, because there are 5 compounds given, which has the same set of elements, which are C atoms, carbon atoms and hydrogen atoms. But even though the elements are same, they have been combined in different ratios. So that gives them different chemical properties. Just because you have the same set of elements, which are carbon atoms and hydrogen atoms, that does not mean that these compounds have the same chemical properties. Methane has different chemical properties when you compare it with the chemical property, when you compare those properties with the chemical properties of hexane. And that is also different from the chemical properties of benzene. Why? Even though the elements are same, the ratio in which they are being combined are different. Okay. So in methane, the ratio is, children, 1:4. But if you take hexane, it's 6:14. You can simplify it. If you take benzene, it's C6H6. So if you take acetylene, it's C2H2, 2 C atoms and 2 H atoms. Likewise, okay. And then the next 5 compounds, they are being made out of C, H, and O. Okay, glucose, that you all know, it's a simple sugar, glucose that have been produced by plants because of photosynthesis, C6H12O6, and you have acetic acid that is in vinegar, CH3COOH, ethanol, which is present in alcoholic beverages, beverages ethanol, C2H5OH, and dimethyl ether, which is an anesthetic, CH3OCH3, sucrose contained in sugarcane එකේ තියෙන sucrose, හරිද? C12H12O11, C12H22O11. Okay, so ඒවා වල එකිනෙකට ඒගොල්ලන්ගේ මේවා වෙනස්, chemical properties වෙනස්. මොකද යාලා එකතු වෙලා තියෙන ratio එක වෙනස් නේ. ratio එක වෙනස් වෙනවා එකම elements තිබ්බ. දැන් අපි glucose ගත්තත් carbon atom එකයි hydrogen atom එකයි oxygen atom එකයි තියෙන්නේ. acetic acid ගත්තත් එහෙමයි. carbon එකයි hydrogen එකයි oxygen එකයි විතරයිනේ තියෙන්නේ. හැබැයි ඒවා වල තියෙන මේ ratios වෙනස් වෙනවා. දැන් C6 H2LO6 ඒත් අරක එහෙම නෑනේ. ඇසිඩික් ඇසිඩ් ගත්තොත් ඒකේ තියෙනවා C2යි. අරකේ 6ක් තිබ්බා. මේකේ H2යි. අරකේ H12ක් තිබ්බා. ඇසිඩික් ඇසිඩ් එකේ තව O තියෙන 2යි. ග්ලූකෝස් වල 6ක් තිබ්බා. So the ratios are different. So because of that, the chemical properties are also different. That is why they have written here very clearly, crystal clear, children. The different compounds formed by even the same set of elements have different chemical properties. I hope that's clear. Okay, so now we are moving on to mixtures. I hope you all can remember, because in the top, like last week when we started the lesson, I told you all that matter which has a space and which occupies space and also has a mass, that's been divided into two as pure substances and non-pure substances. So today we are going to talk about the non-pure substances part, which is mixtures. Okay. So now they have given you an example. Just think about seawater. So seawater has different kind of salts and different gases dissolved in it. So if you take NaCl තියෙනවා seawater. තව එතකොට oxygen dissolve වෙලා තියෙනවා. carbon dioxide dissolve වෙලා තියෙනවා. එක එක salts ජාති dissolve වෙලා තියෙනවා, gas ජාති dissolve වෙලා තියෙනවා. නිකන් අච්චාරුවක් වගේ. ඒ වගේ පේන්න නැති වුණාට අන්න එහෙම තමයි mix එකක් කියන්නේ. නිකන් අර ඒ වගේ මින් එකක් තමයි දෙන්නේ. So ඒ කියන්නේ several constituents තියෙනවා. එක ජාති දේවල් තියෙනවා. දැන් ඔයාලා පැන්සල් පෙට්ටියක් ගත්තොත් ඒ පැන්සල් පෙට්ටිය ඇතුලේ තියෙනවා අපේ මොනවද? correction pen එක තියෙනවා, pen තියෙනවා, highlighters තියෙනවා, erasers තියෙනවා, rulers තියෙනවා. එතකොට මොනවද තව තියෙන්නේ? එක එක ඒවා තියෙනවානේ pencil case එක ඇතුලේ. color pencils තියෙනවා සමහරවිට. padding numbers තියෙනවා. අන්න අච්චාරුවක් කරන්නේ ගොඩක් දේවල් තියෙනවා. හරි. එතකොට ඒ සමහර කට්ටියගේ පොතත් තියෙනවානේ. දැන් අපිට හිටිය සමහර යාළුවන්ගේ පොතේ තියෙනවා සයන්ස් උත් තියෙනවා කියලා. ඒ පොතේ ඊට පස්සේ මැද පිටේ ඉඳන් ඉතුරු ටිකේ maths, ඊළඟට පිටිපස්සේ ඉඳන් අනිත් ඉස්සරහට history තියෙනවා. අන්න ඒ වගේ like you know ඒකේ several subjects තියෙනවා. දැන් pencil case එකේ තිබ්බොත් pencil case එක ගැන කිව්වොත් several stationary matters තියෙනවා. stationaries තියෙනවා. හරි ඒ වගේ තමයි. sea water එක ගත්තොත් එහෙම එක එක ಜಾති salts තියෙනවා, gases තියෙනවා dissolve වෙලා. අන්න එහෙම. හරි. so ඒ වගේ තමයි the non-pure substances කියන්නේ එක එක constituents තියෙන substance එනවා. So yeah, sea water is a mixture. And also children, if you take the natural environment, there are mixtures and we come across mixtures and not pure substances. So most of the time in the nature අපිට අර එහෙම පිටින්ම කියන්නේ pure substances හම්බෙන අඩුයි ගොඩක් වෙලාට තියෙන mixtures. එයා එකත් එහෙම. හරිද? එයා එකේ තියෙනවා nitrogen තියෙනවා, oxygen තියෙනවා, carbon dioxide තියෙනවා, argon තියෙනවා, water vapor තියෙනවා, එක ඒවා තියෙනවා. එතකොට soil උත් එහෙම. River water, rocks, they are all made out of mixtures. Okay. So if you take yogurt, that is also a mixture. මොනවද කිරි විතරද ඒකෙන් හදලා තියෙන්නේ නෑනේ එක එක දාලා නෙම හදන්නේ ice cream, fruit salad is a perfect example for mixtures. Because why? fruit salad කියන්නේ fruit salad එකක් salad එකක් නේ ඒකට තියෙන ඔක්කොම දාලා pineapple, mango, banana. Oh my god, that makes me hungry as well now talking about fruit salad. And there's a picture right here. There's coffee and ice cream, fruit salad. It makes me hungry. I should better do it like this so that I won't see those pictures. So anyways, so yogurt, ice cream, fruit salad, they are all mixtures. Okay. And tea, coffee, soft things, ඒවත් mixtures තමයි. ඔයගොල්ලන් තේරෙනවද දැන් yogurt අපි mixture එකක් කියන්නේ ඇයි ඒ විදිහටම තමයි coffee, tea, soft drinks වගේ ඒවා they are mixtures as well. Okay. So yeah, there's a very appetizing fruit salad and a coffee and ice cream of different flavors here. I don't think I want to just look at that. And yeah, let's do it like this. Okay. And then you have mixtures. They are being formed when two or more pure substances get mixed. So mixtures කියන එකට හොඳම definition එක මොකද්ද? pure substances hari kamanna deka tunak mix unam tamai mixture එකක් හැදෙන්නේ. දැන් අපි හිතන්නකෝ මෙහෙම දැන් ළමයි හිතන්න ඕන හොඳ ළමෙක් ඉන්නවා. There is a good girl called let's say Amara, and there's a good girl called Kamala. There's a good girl called Nayana. Okay, and there are some but then these people have different 90% of their characteristics are good, 10% හොඳ නැති දෙයක් නේද? අපි අමරව ගත්තොත් එයාගේ ඔක්කොම හොඳ හැබැයි බොරු කියනවා. හැබැයි ආ වෙන මුකුත් කරන්නේ. හරිද? වෙන අයගේ මුකුත් දෙයක් ගන්න නැහැ. නරක වචන පාවිච්චි කරන්නේ නැහැ. බොරු කියනවා. දැන් අනිත් එක්කෙනා ගත්තොත් දැන් මට යූස් කරපු තුන් දෙනාගේ නම් තුන මතකයි. කමලා නායනා අමරණි කියවේ. හරි. කමලාව ගත්තොත් කමලා is all good, බොරු කියන්නේ නැහැ. හැබැයි කේලම් කියනවා. අනිත් එක්කෙනා අමරා ගත්තොත් එයා කියන්නේ හැබැයි අනිත් අයගේ දේවල් ගන්නවා. හරිද? මේකලන් ඊට individually ගත්තොත් they are good because like 90% they are good, but they have this 10% of traits where those traits are not that good. Okay, so if you take Amara is really good, but the thing is she lies. Kamala, she doesn't lie, but the thing is she goes on telling around other people's stuff, gossiping, and she's like that. And then there's this other girl who does not say lies or gossip, but the thing is she not steals, but she tends to take other people's stuff. Okay, so if you take individually, they are like that. But children, now one day these three people, they become friends. So now Kamala, Amara, and Nayana, they become friends. Now what happens? Now Kamala looks at the other person and then she thinks, oh my god, this person gossips. I should also start doing this. And then the other person thinks, oh, that person tends to, take other people's stuff. Why should I also should start doing it. That person might start thinking about that like that. Now what happens? These three children gets together. They are friends now. And then they become a set of they become bad friends, a set of bad, a bad set of friends. Okay, why? Because that set has a person who lies, that set has a person who gossips, that person has a person who tends to take other people's stuff. Okay, so then ඊට පස්සේ මේකලා යාළුවෝ වුණාම මේකලන් අනිත් එක්කෙනාගේ characteristics traits exchange වෙනවා. දැන් ඉතින් අරයත් එක්ක ඉද්දි අරයා වගේ වෙනවා. අන්න එහෙම. අන්න එතකොට ඒක නරක සෙට් එකක් වෙනානේ යාළුවෝ. කවුරු හරි දැක්කම අයියෝ ඒගොල්ලන් they are not that good because those people they lie and they gossip, oh my god, and they also tend to take other people's stuff. මගෙත් පැන්සල් අරන් ගියා අන්න එහෙම සෙට් එකක් වෙනා ඒ සෙට් එක. ඒතර දැන් ඒගොල්ලන් හොඳ යාළුවෝ සෙට් වෙන්නේ. Okay, so that is not relevant to this lesson, but what I'm trying to say is, so a mixture is also like that. Mixture එකක් අපි non pure කියන්නේ මොකක්ද? ඇයි pure substances දෙක තුනක් ගොඩක් එකතු වුණාට පස්සේ එක non pure එකක් වෙනවා. එතකොට අපි ඒකට mixture එකක් කියලා කියනවා. හරි. දැන් sea water ගත්තොත් ළමයි sodium chloride තියෙනවා කියලා මම කිව්වනේ. Now if you take sea water, I told you all that sodium chloride is in sea water. Sea water comprises sodium chloride. Okay, so if you take sodium chloride, it's not an unpure substance. It's not an unpure substance, right? It's a compound. I told you all in the previous section when we were learning about compounds. So sodium chloride is a compound. Okay, so and seawater comprises sodium chloride as well. Then sodium chloride can compound. හැබැයි මේ seawater ගත්තොත් seawater के sodium chloride විතරක් නෙවෙයි තියෙන්නේ. ඒකේ oxygen dissolve වෙලා තියෙනවා, carbon dioxide dissolve වෙලා තියෙනවා. එතකොට ඒව individually ගත්තට pure substances කියලා ඒව ඔක්කොම එකතු වෙලා seawater එක අපි as a whole ගත්තොත් seawater කියන්නේ mix එකක් which is a non-pure substance. I hope that's clear, okay? So see, the pure substances in a mixture are called as constituents. Then sodium chloride කියන්නේ seawater එකේ තියෙන constituent එක. හරි දැන් අපි අර යාළුවෝ සෙට් එක ගත්තොත් ඒ නරක යාළුවෝ කට්ටියගේ අමරා කියන්නේ එක constituent එක. අනිත් අපි මේ lesson එකට relate කරත් it's like that. Okay, Amara is one entity. Kamala එකෙනෙක් නායනා කෙනෙක් එහෙම. අන්න ඒ වගේ තමයි මේක. හරි. ඒ කියන්නේ අපි sodium chloride කියන්නේ එක pure substance එකක්. ඒ කියන්නේ යා මේ lesson එකේ විදිහට constituent එකක්. එහෙම ඒ constituents එකතු වෙලා තමයි ඒ කියන්නේ pure substances එකතු වෙලා තමයි mixture එකක් හැදෙන්නේ. So the pure substances in a mixture, they are known as constituents. And they have given examples here. Air, the constituents are nitrogen, oxygen, argon, carbon dioxide, water vapor. So what is the gas in the atmosphere? Like what do we have the most predominant gas? Nitrogen. Okay. Even though we inhale oxygen, it's nitrogen. Nitrogen is my atmosphere. And then we have seawater, the cake mixture. Cake flour විතරක් දාලා හදන්න බෑනේ. Sugar, flour, water, coloring, butter, eggs ඔක්කොම තියෙනවා. Crude oil, diesel, petrol, kerosene, tar ඒ හැමදේම එකතු කරලා තමයි crude oil හැදෙන්නේ. Okay? The specific feature of a mixture is that its constituents can be separated by physical methods. Yeah. මෙතන තියෙන හරිම special feature එකක් තමයි y'all can underline it. මේකේ තියෙන constituents අපිට separate කරන්න පුළුවන් physical method එක. දැන් අපි cake එකක් ගත්තොත් අපිට කෙනෙක් හිතනකොට අමාරුයි, but there are methods where we can actually separate these constituents by physical methods. Okay? When rice is mixed with sand, they can be separated by sifting using the sifting bowl. And then අපි දමුකෝ දැන් අපිට ගොඩක් අය හාල් එන්නේ වැලිත් එක්ක අර එකපාරට අපි අපිට ගලක් හැපුණා කියලා කියන්නේ. ඒ ඉඳලා හිටලා එහෙම ගලක් තියෙන පුළුවන්, but ඇත්තටම තිබ්බොත් ඒ හාල් එක අර කඩලා එද්දි ඒවා තියෙනවා වැලි කැට හැපෙනවා එහෙම. ඒකට මොනවද කරන්නේ? ඒවා නොවෙන්න මොකද අපි කරන්නේ? අර මොනවද කියන්නේ? what do you call sifting ගරන y'all know right, sifting එහෙම sifting bowl එකක දාලා ගරලා තමයි හාල් ගන්නෙ. So sifting is a physical method of separating constituents in a mixture. So sifting කියන්නේ එක method එකක්, physical method එකක්. හරි. එතකොට තව දේවල් තියෙනවා. Now let's talk about them as well. So now these are the methods, children. Panning, එතකොට sand from rice. හාල් වල තියෙන නිකන් වැලිකට එහෙම අයින් කරන්න පුළුවන්. And oils වල තියෙන gems separate කරන්න පුළුවන්. And then you have winnowing, separating chaff from rice. chaff කියන්නේ ළමයි අර හාල් එකේ පොත්ත 10 කියලා නේද කියන්නේ හාල් එකේ පොත්ත අන්න ඒක අයින් කරන්න winnowing. That is the method. And floating on water, separating sterile seeds from seed paddy. Sterile කියන්නේ ළමයි the immature seeds. Okay? which does not have the ability of producing yet. And sifting I told you all about it. So sand වල තියෙන gravel line කරන්න ඔක්කොම අර ගරන වැඩ ඒවා කරන්න බෑ sifting වල. You have evaporation, obtaining salt from seawater. ඒවා චුට්ටක් ගෙවල් වල ගන්න බෑ ඒවා. So evaporation කියන්නේ මොනවද? අර වතුර seawater එකේ seawater වතුර ටික evaporate වෙනවා දෙනවා. එතකොට මොකද වෙන්නේ? salt ටික ඉතුරු වෙනවා. salt කියන්නේ gas එකක් නෙවෙයිනේ. හරි. එතකොට දැන් ඒ seawater කියන්නේ gas එකක් නැතුණාට ඔයගොල්ලෝ දන්නනේ water vapor කරන්න පුළුවන් කියලා. එතකොට water vapor කරලා ඒවා evaporate කරනවා, and then you can obtain the salt. And then you have fractional distillation. And what is the function? What is the use of it? You can separate the fuels from crude oil. Then crude oil අපිට තියෙනවා constituents කතා වුණානේ මෙතන. Diesel, petrol, kerosene, tar අනේ ඒවා එක එක වෙන separate කර ගන්න පුළුවන් using fractional distillation. And children, it's good if you all can check some YouTube videos of practical implications of these methods. Fractional distillation කියලා ගහන්න. එතකොට ඒක කරන විදිහ fractional distillation of crude oil කියලා ගහන්න ඒක කරන විදිහ පේනවා. Evaporation of seawater කියලා දාන්න. Evaporation of seawater to obtain salt කියලා. ඒතර ඒක පේන්නේ. මොකද when you learn something by watching something, it goes to your head. So I think that is why we thought of doing conducting lessons like this, because here you can see and also learn and hear as well. So it will be more effective rather than just reading the book and studying. Okay. And then you have steam distillation, cinnamon oil separate karan pula, cinnamon leaves and crystallization, separating sugar from cane sugar syrup. Cane sugar syrup again sugar separate karan and crystallize kalla. Magnets use karala, mineral sands minerals, samahara minerals separate karan pula. So these are some physical methods. So y'all might get an MCQ nikam shift in dala. What is the instance? Or else you have been given the this thing, the function, and to select, you have been given the function so that you could select the correct physical method. Then obtaining salt from seawater, panning then winnowing then sifting then evaporation. Now you all can use, you all can use your common sense and write evaporation for that, because seawater is water. You can vaporize it and let the water vaporize, let the water evaporate, and then you will end up with salt. So that's one method. Okay. And then children, so mixture, we talked about it. It is a matter which consists of two or more constituents and which can be separated by physical methods. Now, our product calling the definition of the කෑල්ලක් add වෙලා මොකද add වෙලා තියෙන්නේ මේ constituents physical methods වලින් අපිට separate කරන්න පුළුවන්. ඒකට ඔයාලට හොඳ definition එක ලියන්න ආවම ලියන්න පුළුවන් කියන්නේ MCQ වගේ නම් බෑනේ, that you all just underline the correct answer. So if you get a structured or an essay question about mixtures, මේ definitions දෙක වගේම එකතු කරලා දාන්න ඕනේ. And so a matter, it consists of two or more constituents and they can be also separated by physical methods. So there are two types of mixtures, as homogeneous and heterogeneous. Yeah, homogeneous. Well, a ගොඩක් වෙලාවට තියෙන characteristics තමයි ළමයි, their color, they have transparency ගොඩක් වෙලාවට. And ඒක වගේ කියන්නේ color එක transparency එක transparency තියනවා කියලා නෙමෙයි මම කියන්නේ. දැන් තියෙන transparency එකයි color එක throughout the mixture එක වගේ. උඩින් බැලුවොත් අපි glass එකකට මොනවා හරි solution එකක් දැම්මොත් උඩින් පේන විදිහත් එක වගේ යටත් එහෙමයි, it's constant, the transparency and the color. Okay, and there's a uniform composition. Uniform composition can be constant. එක වගේ තමයි composition එක තියෙන්නේ. අඩංගු වෙලා තියෙන දේවල් තියෙන එක විදිහට. So they are homogeneous. දැන් salt solution එකක් දැන් කෝප් එකට වතුර ටිකයි ලුණු ටිකකුයි දාන්න. කොහෙන් බැලුවත් වටින් කොහෙන් බැලුවත් එක වගේම solution එකේ. sugarත් එහෙම. sea waterත් එහෙමයි සාමාන්‍යයෙන්. අපි වතුර ටිකක් මෙතනින් ගත්තත් එක වගේ, මොහොතේ තව තැන චුට්ටක් ගත්තත් එක වගේ අතට එන ටික අර there is an uniform composition in a mixture. So those ones you call them as homogeneous mixtures. එක වගේ alike. Okay, so alike කියන්නේ මේ තියෙන දේවල් නෙමෙයි, අර transparency එක, composition එක, color එක throughout the mixture same now. If that's alike, then they are homogeneous mixtures. And heterogeneous mixtures are the opposite of homogeneous mixtures. So that means the color and the transparency of the mixture is different from place to place. Place to place කියන්නේ මේ අපි muddy water කොළඹ ගෙනාවම එක විදිහක්, නුවර ගෙනිච්චම තව විදිහක්, ගාලට ගෙනිච්චම එක විදිහක් නෙමෙයි. අපි මොන හරි මොකක් හරි භාජනයකට හරි මොකක් හරි එකකට දැම්මට පස්සේ අර පේන composition එක ගොඩක් වෙනස් නම් then it's a heterogeneous mixture. So if you dissolve some clay in water and then you just time to time go and check it out, so the transparency and the color is different from place to place. Again, වතුර වලනේ අපි dissolve කරලා තියෙන්නේ. එක තැනකට යතදයි, තව තැනකට ලාවට ඇවිල්ලා අන්න ඒ වගේ light වෙලා, තව තැනක හරිම dark අන්න එහෙම. So the mixtures in which the composition is not uniform throughout the mixture, they are known as heterogeneous mixtures. They are not uniform. The composition is not uniform throughout the mixture. The examples are children, muddy water, mortar mixture, ice cream, fruit salad. So they are heterogeneous mixtures. Okay, so that's the end of it. And next week we can talk about the next lesson, the fourth lesson, children. And this is also a very special lesson because the first two lessons we did about microorganisms and then we learned about the eye and the ear. So first microorganisms and then eye and the ear. All those were biology lessons. Okay, so it was related to biology. That is the branch of science. And then last week and this week we learned about uh, one of the basic chemistry lessons. Okay, so we learned about compounds, elements, mixtures, atomic structure, atoms, neutrons, protons, electrons, and nucleus. Those were the basics of chemistry. So we moved on to chemistry when we started learning about the lesson 3. And next week we'll be learning about the first lesson of physics. Okay, so physics is a bit different from biology and chemistry, because biology children, you all have to learn a lot. There are so many facts to learn. You all can't just think and write stuff. Those are science. So that's science, and some of the laws and some of the stuff are being put forward, like they are being put forward by scientists. And yes, so you can't just write yeah babe. There are some instances, but most of the time you have to study by heart. Okay, katapadam karanu. And then when we talk about chemistry is also like that. You all have to study. So obviously, you all can't just write the chemical formula of copper sulfate. You all have to know that it's CuSO4. Copper sulfate is CuSO4. So you all have to learn it. Okay, but the facts you all have to, the amount, the bulk you have to learn when compared to biology is a little bit less. Physics children, the lesson we are going to learn about next week is forces. And physics children, there's not much to study like biology or chemistry, but there are you'll have to do some sums. But ganang karana dena habe lazy eva karina luku ganang neveyi, but there are some sums. So maths is a bit involved in physics, and it's interesting. It's so interesting. Okay. So next week we'll be moving on to the basic lesson of physics, and then we'll be having more biology, chemistry, physics lessons in the future as well. So children, stay safe, like I always tell y'all, and be happy. And if there's anything y'all want to ask from me, just write it in the comment section. It doesn't matter whether you all watch this video tomorrow, today itself, or after 2 or 4 months. I really like that, doesn't matter. Just type the question whenever you see this video, and if you come up with a question, I'll be so happy to answer y'all. Even after so many years as well, if I see the comment, I'll be really happy to answer to answer y'all. Okay, so yeah, then thank you, bye, take well care of yourselves and be happy. Good luck for your future endeavors. Study well and let's do it. Bye.